In this video, we will discuss an example, or do an example of a function we want to look for. We are looking for the horizontal asymptote and the vertical asymptote of this given function. So that's our example. We are given two functions. We are given one function, right? Our function here is given by f of x equal to 2 times e to x over e to x minus 5, right? So we give a quotient function here. And what we want to do here is we want to find the horizontal uh asymptote and vertical asymptote of f, right? So recall that horizontal asymptote just means the limits, possible limits at infinities, right? Infinities, right? Positive and negative infinity, and right, finite limit. If you have limit is infinity, you don't have a horizontal asymptote. And vertical asymptote is you look at which number you have a infinite limit, right? That's their difference. One is you are looking at the limit at infinities. The other one is look at a number such that at this number, the limit is infinity, right? So let's start from a horizontal asymptote. Horizontal asymptote, right? So we want to evaluate two limits because we have two infinities. One is positive infinity, the other one is negative infinity, right? And this is go to infinity, f of x. The other one is as x goes to negative infinity, f of x, right? So this is equal to as x goes to infinity, 2 times e to x over e to x minus 5, right? By our discussion before, we know that as x goes to infinity, e to x is infinity. As x goes to negative infinity, e to x is 0. So that's some elementary fact we know, right? So this one here is basically infinity over infinity, right? So we want to put the infinity term into a denominator to evaluate the limit. So this is same as x goes to infinity. Infinity term for sure is e to x because that's the term go to infinity. We do a division, right, on both numerator and denominator by that term, right, times 1 over e to x. So this is equal to as x goes to infinity, you get 2 over 1 minus 5 e to x, right? So a number over infinity is 0. So plug in 0, you get this is 2, right? And this one is even easier. So this is as x goes to negative infinity, you get 2 times e to x over e to x minus 5. We know that as x goes to negative infinity, e to x goes 0. If you plug in 0, you get 2 times 0 over 0 minus 5, which is 0, right? So this is 0, that's it. So which means you have two finite limits at infinities. One is at positive infinity, the other one is at negative infinity. So we get two horizontal asymptote, y equal to 2 and y equal to 0 are the horizontal asymptote of y equal to f of x, right? Now let's look at the other one, right? Vertical asymptote, right? So this is we are looking for the numbers at which the function go to infinity. So the function go to infinity is then the denominator has to be go to 0, right? So basically you are solving for you are starting from the solutions of the equation by setting the denominator equal to 0, right? So we get that equation. Our denominator is e to x minus 5. So we set that, right? This is equal to 0. We get x is natural log of 5, right? So remember that if you want to get a vertical asymptote, all you need is a one side limit is infinity, because sometimes left side goes to negative infinity, right side goes to positive infinity, so the limit may not exist. So we just evaluate one limit, right? One-sided limit. So let's look at what's the limit of this function as x goes to natural log of 5 from the right side, right? You get 2 times e to x over e to x minus 5, right? If you try to plug in the values for x, the numerator goes to 10, right? Denominator is getting closer and closer to 0 on the right side, right? We should notice as x goes to natural log of 5 from right side, then 2 times e to x goes to 10, and e to x goes to 5 positively, right? So minus 5 goes to 0 plus. You get 10 over some 0 plus. It's getting closer and closer to 0, but positively, right? And so this is clearly positive infinity. So this means x equal to natural log of 5 is a vertical asymptote of y equal to f of x. And that's the only one, because that's the only number make the denominator equal to 0, right? So to identify the vertical asymptote, you are starting from the root of the equation obtained by setting the denominator equal to 0, but some root may not be a vertical asymptote, and some could be, right? That's our starting point. So that's how do we starting with a function and identify the horizontal asymptote and vertical asymptote of such a function.